Hello everyone. In this video, we'll be discussing paper 3, that is Advanced Practical Skills from AS Level Chemistry. This paper is taken from the year 2021 and the series is per March. The paper code is paper 33. So in the previous video, that is first part of the video, we have already seen the solution for question number 1. If you haven't watched that video, I will give the link in the description. So in this video, we'll be looking at the second question. So this is part 2 of this paper. So in part 2, the question that we'll be discussing is the second question. So the question says, in this experiment, you will determine the relative formula mass of same metal hydrogen carbonate. So the metal hydrogen carbonate is the same. So we are going to determine the element M through a different process, that is using thermal decomposition. Then you will compare the result obtained with your answers from 1C4. Okay, so this is what we are going to do. We are going to find the metal in the given salt, that is metal hydrogen carbonate, and then we are going to compare the results obtained with the first result. So it's said that Fa4 is another sample of the metal hydrogen carbonate, MHCO3. So let's dive into the process. So over here, the method says, first, weigh the empty crucible with its lid, record the mass. So first itself, you have to record the mass of empty crucible with its lid. So let's do that. So mass of empty crucible, you can directly write whatever is given in the question. So over here, it is given that empty crucible with lid. So we'll write the same mass of empty crucible plus lid. This should be in grams. And then the next process is to transfer all the Fa4 from the container into the crucible and weigh the crucible, lid and Fa4 and record the mass. So again, we have to record this mass, that is the weight of the crucible with lid and Fa4. So we'll write that. So the next point is to calculate the mass of crucible plus lid plus Fa4. This also will be in grams. And then we have to calculate and record the mass of Fa4. So this is not to be weighed and recorded, rather it is to be calculated and recorded. So from the masses that you obtain, you will be calculating the mass of Fa4 used. Okay, so mass of Fa4 used. And then we'll do the further process, that is to place the crucible and the contents on a pipe-clay triangle. Heat the crucible gently with the lid on for approximately 1 minute, and then heat it strongly with the lid off, that is without the lid, for 4 more minutes. And then we will leave it to cool for at least 5 minutes. So while you're cooling, you can go ahead and do the third question. Okay. And then after 5 minutes, once the crucible is cool, we have to weigh the crucible with its lid. Okay. So this is after first heating. After the first heating, we are weighing the crucible with its lid and contents. So this contents can be considered as a residue, because whatever is left after the experiment is called as residue. So we'll write that. So mass of crucible plus lid plus residue after heating. This is the first heating, so we will mention that in brackets, okay? After first heating, this is also in grams. And then we are heating it strongly, heat strongly with the lid off for further 2 more minutes. Replace the lid and leave the crucible to cool for at least 5 minutes. When the crucible has cooled, reweigh the crucible with its lid and content and record the mass. So again, we are heating it, that is, we are heating it for the second time and allowing it to cool, and then we are reweighing it again. So that will be the next recording, that is mass of crucible plus lid plus residue. So plus residue after heating 2. And then they're asking us to calculate and record the mass of the residue obtained. So the last one will be mass of residue obtained. That is also in grams. All these are in grams. So we will make it into a tabular column. It's always a good practice to use scale and pencil to draw the tabular column. So over here, these are the rows wherein you will be doing weighing the substance and writing the mass. And the unit for all these is in grams. And it's always a good practice to have at least 2 decimal places while weighing equipments or substances. Okay, so 2 decimal places. So according to my experiment, the values that I got will be written in this table. So I got the mass of empty crucible plus lid as 46.81. It is in grams. Grams is already written over here, so I'm not rewriting it. Then the mass of crucible plus lid and Fa4 is 49.01 grams for me. So now the next is mass of Fa4. Remember, this was given as calculate. So which means you have to use the values that you got to calculate Fa4. So what will be Fa4? Mass of Fa4? Nothing but this weight minus this weight. Because if you see over here, only Fa4 is the addition, right? So if you want to get the mass of Fa4, you can just subtract mass of crucible plus lid plus Fa4 minus mass of crucible plus lid. So when we do that, it will be 49.01 minus 46.81, which will be equal to 2.20 grams. Always use 2 decimal places. That's why I'm using 0 in the end. Then mass of crucible plus lid plus residue after heating for the first time. For that, I got the value as 48.55, and after second heating also my mass remained the same, that is 48.55 grams. For some people it may vary. If you are varying, make sure that the difference between the first and the second does not exceed 0.04 values. Okay, because if that varies, then marks will be detected. So almost your weight should be constant between the first and the second heating. So the last one is to calculate the mass of the residue obtained per gram. So here also it is to calculate. So from the obtained values, you will have to use some equation and calculate the mass of the residue. So when we are calculating the mass of the residue, we have the residue plus crucible plus the lid, right? And if we want to get the residue alone, we initially had the mass of the crucible and the lid, right? So crucible plus lid, we already know it was 46.81, and mass of the residue plus crucible plus lid was 48.55, which we got it after the second heating, right? So that if we subtract that, then the crucible and lid will get cancelled and only residue will remain, right? So we will subtract the mass of crucible plus lid plus residue after the final heating from the mass of crucible plus lid to get the value of the residue. So it is 48.55 minus 46.81, which will give the value as 1.74 grams. Okay, so I hope this is clear. Now, once this is done, we are getting the mass of the residue. Now we just have to do the calculations. So when we are going to do the calculations, there is the first question is asking us to pour 1 centimeter depth of dilute hydrochloric acid into a test tube, add a spatula measure of residue Fa5 to the acid. So we have to do this experiment and see. That is, we are taking hydrochloric acid and we are adding Fa5, which is the residue that is obtained. After that, record all your observations and identify any gas form. So you are asked to record all the observations with gas form, and this is for 2 marks. So when they are asking you to record all the observations, probably you will have to write at least 2 to 3 points. So since the mark is 2 marks, usually the allotment will be 4 points. So each point will have half a mark weightage. But remember, there is no half marks given in AS or IG levels. Only if you write 2 points, you will get 1 mark. If you write 1 point, if you write only 1 point, you will get 0 mark. Okay. So that is how the marking goes. So make sure to write the points correctly to get all the 2 marks. So the first observation that I saw, since this compound contains hydrogen carbonate. So obviously, when we try to test the gas, or when we add it to HCl, this is going to act as a base and HCl is going to act as an acid. Okay, so we have already seen that metal carbonate plus HCl or plus acid gives corresponding salt plus water plus CO2. So when we add acid, we are going to get carbon dioxide, and they are asking us to test the gas produced, right? So obviously this gas is going to be carbon dioxide. So we'll be doing the test for carbon dioxide. So the test for carbon dioxide gas would be this one, that is carbon dioxide gives a white precipitate with lime water. So we have to do the test with lime water. So first, when we add this, at that time itself gas will be produced. So obviously we'll be able to see fizzing or effervescence because of the formation of gas. And then we have to do lime water test. So that will be the second point. So since it is carbon dioxide, the lime water will turn milky. Sorry, lime water turns milky. And then we will be able to see that the solid that we have added is going to disappear. So the solid dissolves in the acid. So that is the third point that I observed. And the last is to identify the gas formed. So the gas formed, usually we won't be writing the identity of the gas. If you take salt analysis and all, we'll write the identity at the end. But over here, since it is asked in the question, we'll write it. So CO2 is the gas formed. So 4 points for 2 marks. Because they are asking us to write all the observation and identity. So definitely it's going to be 0.5 marks for each point. Now, use your observations in B1 to identify the anion in Fa5. So assume all metal hydrogen carbonate has decomposed. So for this question, we have to know how the decomposition of metal hydrogen carbonate takes place. So first, we'll try to do this question and then come to the second question. Okay, so whenever a metal hydrogen carbonate decomposes, it forms metal hydrogen carbonate. When it decomposes, it forms metal carbonate. Okay, so this is the compound that will be formed. Now, in order to check the formula, we'll have to look at the compound metal hydrogen carbonate. So metal hydrogen carbonate is an ionic compound. So when we try to look at the charges, hydrogen carbonate has a charge of -1. So definitely the metal should have +1, then only the formula of this compound will become MnCO3, right? We have already studied how to do the formulas of ionic compounds. We will crisscross it to get the value. Since metal also has a subscript of 1 and hydrogen carbonate also has a subscript of 1, it means both the compounds should have the same charge, then only they will have subscripts of 1. So which means the metal belongs to the first group. And already in the first question itself, it is being mentioned that the metal belongs to group 1. So group 1 metals have a charge of +1. So the formula of the metal carbonate formed can be determined using that. So CO3 has a charge of -2, and the metal, since it belongs to group 1, it has a charge of +1. So when we crisscross it, the compound will have a formula N2 because the subscript 2 goes to N when we crisscross it. So N2CO3 will be the formula. Okay, so this while answering this question, one of the compound will be metal carbonate, M2CO3. So that is the salt. This is the salt that is formed. So now if you look at the salt, the anion will be the compound other than metal. So the anion over here is CO3 2 minus. So that gives the answer for the second question. Now, trying to complete the third question, they are asking us to write an equation for the thermal decomposition. It is being clearly said that steam is produced when metal hydrogen carbonate is thermally decomposed. So the salt is already known, right? What do you mean by steam? Steam is nothing but water in gaseous state. So the next byproduct would be water, and that too in gaseous state. The salt will usually be in solid state because carbonate salts are insoluble in water. Okay, so now when we are trying to balance it, since there is 2M over here, we will put 2 in front of MHCO3. And then if we try to balance carbon, there is 2 carbons in the reactants, and in the product also 1 and 2 carbons are there. So carbon is balanced, 2 and 2 balanced. Then oxygen is there. Oxygen is 2 into 3, 2 into 3 in the reactant side, so which will be equal to 6. And in the product side, there is 2 oxygen over here. And then 3, and then 1 oxygen. So 2 plus 3, 5, 5 plus 1, 6 oxygen. So oxygen is also balanced. And now coming to hydrogen. Hydrogen is 1 into 2 in the reactant side. So 1 into 2 in the reactant side, which is 2. And in the product side also it is 2. And therefore, all the compounds are now balanced. So the balanced chemical equation would be, for this particular equation, would be 2 metal hydrogen carbonate gives 1 carbon dioxide plus 1 metal carbonate plus 1 water. Now, moving on to the next question. The next question says the number of moles of carbon dioxide given off during thermal decomposition is given by the formula below. So moles of CO2 is equal to mass lost during heating divided by MR of CO2 plus MR of H2O. So how do you calculate the mass lost during heating? So we know the residue is having a mass of 1.74. So residue has a mass of 1.74. And initially when we had taken Fa4, that is the mass of Fa4 used was 2.2. So initially we had 2.20 grams of Fa4, and then it became 1.74. So something is being lost over here. That is why there is a difference, right? So the mass lost will be obtained by subtracting this mass of Fa4 and residue. So it will be 2.20 minus 1.74 divided by mass of carbon dioxide. For carbon dioxide, there is 1 carbon, which has a mass of 12, plus 2 oxygen, whose mass is 16, will give you the mass of CO2, plus mass of water will be 2 into mass of hydrogen, or AR of hydrogen, plus 1 into AR, atomic mass of oxygen, which is 16. So if we try to solve this, the answer that we obtain will be 7.41 into 10 raised to minus 3. It's always a good practice to have at least 2 to 4 significant figures, and always write it in the power of 10. Okay, rather than writing it as 0.00741, you can write it as a power of 10. Now, The next question is to calculate the relative formula mass MR of metal hydrogen carbonate. Show how you obtain your answers using your data from question 2. So for this, we know that number of moles is equal to mass by MR. And we are asked to find MR. So MR will be mass by M. That is number of moles. So we are asked to calculate it for MHCO3. So mass of MHCO3 is to be taken and the number of moles of MHCO3 is to be known for calculating MR. So we haven't found the number of moles of metal hydrogen carbonate, but we have found the number of moles of CO2. So from the balanced chemical equation, we can definitely find the number of moles required for metal hydrogen carbonate. So let's take that. So the ratio of coefficients of CO2 and metal hydrogen carbonate are in the ratio 1:2, right? One CO2 gives 2 metal hydrogen carbonate. So that is in the ratio 1:2. So we are multiplying the coefficient of CO2 with 2 to get the coefficient of metal hydrogen carbonate. So same can be applied for knowing the number of moles of CO2. Whatever is the number of moles of CO2, that when we multiply with 2 will give you the number of moles of metal hydrogen carbonate. So over here we had 7.41 from previous question. We got the answer of number of moles of carbon dioxide as 7.41 into 10 raised to negative 3. So that into 2 will give the number of moles of metal hydrogen carbonate. So we are sure about the number of moles of metal hydrogen carbonate. And to know the mass of metal hydrogen carbonate, we will go back to the table and we'll see the amount of Fa4 used. That is the amount Fa4 is the metal hydrogen carbonate, which is clearly given in the question, that Fa4 is the metal hydrogen carbonate. So when we try to do that, the mass turns out to be 2.20. So we will use that mass 2.20 divided by 2 into the number of moles of CO2, because that is what we found the ratio of coefficients of CO2 and metal hydrogen carbonate to be. So that will give you the answer as 2.20 divided by 2 into 7.41 into 10 raised to minus 3. So your answer would turn out to be 148.44. And this is the MR of metal hydrogen carbonate. So you don't need any units, as the MR doesn't have any units as such. Now, the next question is you have obtained the 2 values for MR of MHCO3. One in question C4 and another in question B5. State which values is likely to be more accurate. Explain your answers in terms of practical procedures used. So in the first question also, we had found the MR of the same metal hydrogen carbonate, and we got the MR to be 78.986. So for the first question, it was 78 point something. And in this question, we are getting it as 148.44. So what do you think will be a more accurate value? So if you look at the procedures, we can say that in this particular experiment, the number of steps involved is very less. While in the first experiment, we had to make the solution, we had to weigh the mass first. We had to weigh the mass of the metal hydrogen carbonate, and then we had to make up the solution, and then we had to pipette it out, and we had to take the burette reading. So many readings had to be done, and so many procedures had to be done before getting the final value. So if we make error in the first one, and then the second one, and the third one, and the fourth one, what will happen? The number of error keeps on increasing. Therefore, the difference between the final and the initial, or the actual error-free value and error value, will be so much, because we are making error in each and every step, right? While in this, we only had to weigh the mass, or we only had to do the calculation for mass, and then we had to heat and mass and weigh the mass. So basically, there is only two process that is involved. So because of which the accumulated error or error in each step is not getting added. So we can say that we can go ahead with the MR obtained in question number 2, because let's say 2 is more accurate, as less cumulative error due to fewer steps or process. Okay, so this can be one of the reason. And if you can also write other reasons as well, for example, if you are not getting constant values over here, that is the mass, if the mass is not constant in heating 1 and heating 2, then definitely the first one is going to be more accurate, because the mass is not constant in the second question, right? So you can write that the first one will be more accurate if you are not getting constant mass after heating 1 and heating 2. So any of the process can be accurate. It depends upon your results. So this is about the second part. We'll solve the third question in the third part. I hope you have understood this. Thank you.